Hello, welcome to my video on data structures. This is the third video for the array data structure, and we will be motivating several operations for memory management. In the previous two videos, we have introduced several data access and data management operations. Now we know the rough idea of how to access the data element at any location of the array, insert a data element to any location of the array, and delete a data element from any location of the array. However, there are still some other issues we need to take care of to ensure the integrity of these operations. For example, when we try to insert a new data element, how do we know whether the array has sufficient memory to hold it? If not, how should we request for more memory? On the other hand, when we try to delete the ith element from the array, how do we know that the array is at least holding that many data elements? Or, how do we know if we are deleting a data element from an already emptied array? To address these issues, we would like to introduce several auxiliary operations for memory management. To see what auxiliary operations do we need, let's recall the procedure of the data insertion operation. When the array has no more memory to hold the new data, we will request a new place that has more memory and move the existing data elements from the old place to the new place. We know moving all existing data can be expensive, so we can reduce the frequency of such a data move by requesting more space than we need. For example, in the figure shown here, we have requested for n+3 memory blocks while we only need n+1 memory blocks. In this case, we are sure that the next two data insertions will not trigger any expensive data move. In this case, we know that the number of data elements the array can hold may not equal to the number of data elements the array is currently holding. Therefore, we will refer to the number of elements that the array can hold as capacity and the number of elements that the array is currently holding as size. Based on the definition, we know that the size of an array should always be smaller than or equal to its capacity. For example, in the array shown here, its capacity is n+3 and its size is n+1. Now, when we try to insert a new element into the array, we can simply compare the capacity and the size of the array. When the size is smaller than the capacity, then we can hold the new data element. The comparison requires that we can retrieve the current capacity and size of the array. Hence, the array data structure should contain operations that track the capacity and the size. On the other hand, once we have retrieved capacity and size information and found that we need more space, we would increase the capacity of the array and add the new data element. In this case, both the capacity and size are changed. As a result, we know that the array data structure should also contain operations that can change the capacity and size. Taken together, we will introduce four auxiliary operations in this video. They are checking the capacity of the array, checking the size of the array, changing the capacity of the array, and changing the size of the array. Let's begin with checking the capacity and size of the array. Naively, we can simply scan the array to find their values. However, this could be time-consuming as we need linear time to complete the operation. Instead, we can simply store the capacity and size as two variables, and properly maintain them when the capacity or size is changed. For example, when more memory is allocated to the array, we need to update the capacity variable accordingly. When a new data element is inserted, we need to increase the size variable by 1. And when an existing data element is deleted, we need to decrease the size variable by 1. In this case, when the capacity and size variables are properly maintained, checking the capacity and size can be performed by simply returning the values of the corresponding variables. Now, let's move on to the discussion of changing the capacity. What we need to do is simple. We request a new place with more free space, move the existing data to the new place, and update the capacity variable. For example, in step 1, we find the new place with n plus 3 memory blocks. In step 2, we move the data. And in step 3, we update the capacity variable. To change the size of the array, we first need to check whether the new size is smaller than the capacity. If yes, then we don't need to do anything. Otherwise, we will ask for more space by issuing a request to change the capacity, which is exactly the same operation as what we have just discussed. While the operations that we have learned will only change the size by 1, for example, inserting or deleting a data element, I will want to motivate the need for a more generic size change operation that allows the change to an arbitrary size. Let's consider the following two scenarios. Recall the online business example. Imagine that we are originally selling 500 items, but decide to shrink our business and only sell the top 100 items with the highest customer ratings. When the items are sorted in a descending order of their customer ratings, we can reflect the change into the array by simply setting its size to 100. That is, we tell the array that there are only 100 items being stored, which implicitly discard the rest of the items. This is much more efficient than deleting the 400 items one by one. As a result, we will need to shrink the array to an arbitrary size. Consider another scenario if we are merging our business with another partner. Originally, we sell N1 items and our partner sells N2 items, and assume that no items overlap. Now, we want to store the N1 plus N2 items in a single array. The simplest way to merge the items is to insert each of the N2 items sold by our partner into the existing array. In this case, we will call the data insertion operation N2 times. Note that each data insertion operation bears a risk of triggering a memory reallocation and expensive data move. Therefore, the entire process may move the data around many times, which is quite inefficient. Alternatively, we can first change the size of the array from N1 to N1 plus N2, and store each of the N2 items one by one. In this case, we are sure that the memory is sufficient to hold N1 plus N2 items, and there is only one memory allocation and data move for the entire process. Hence, it is desirable that our size change operation can expand the array into any arbitrary size. Taken together, we need a size change operation that can shrink or expand the array to any arbitrary size. Okay, let's summarize what we have learned in this video. We have introduced two terminologies, the capacity and the size. Capacity refers to the number of elements the array can hold, and size refers to the number of elements that the array is currently holding. The size of an array should always be smaller than or equal to its capacity. Then, we have motivated 4 auxiliary operations that facilitate array memory management. They are checking the capacity of the array, checking the size of the array, changing the capacity of the array, and changing the size of the array. In the next video, I will summarize all operations that we have learned and discuss their implementations. Stay tuned. All right, thanks for watching.